Okay, so in this video, we're going to be solving logarithmic equations, all right? So we just went over solving exponential equations, and with exponential equations, we converted them to logarithms in order to use the properties of logarithms to get the variable down on the main level, okay? So here, with logarithmic equations, we're going to isolate the logarithmic expression, and then we're going to convert that to exponential form, okay? And then we're going to solve the resulting equation for whatever the variable may be, okay? So let's look at the first one here. So we've got the natural log of x equals 8, okay? So the logarithmic expression is already isolated on the left side here. Remember, the natural log has a base of e, so we can rewrite this in exponential form. E to the 8th equals x, okay? On your calculator, just evaluate e to the 8th, and we get an answer of x is approximately 2980.958, okay? All right, let's look at problem 2. Again, logarithms already isolated on the left side here, so let's rewrite in exponential form. So we'd write 2 to the 3rd power equals 25 minus x, okay? Now let's simplify. 2 cubed is 8. I'm going to subtract 25 from both sides. So I get negative 17 equals negative x, and then I'm going to divide both sides by negative 1. So x equals 17, okay? With both these, you can always plug your answer back in and check your work. Alrighty. Number 3. Okay, first thing we got to do, we got to subtract 4 from both sides, okay? So 3 times log 2x, common log, notice the base here is going to be 10, equals 12. So 16 minus 4 is 12, okay? Still don't have the logarithm totally isolated. I've got to divide both sides by 3. So log 2x equals 4. Okay, again, the understood base here is 10, so I'm going to rewrite this as 10 to the 4th equals 2x. Okay, 10 to the 4th power is 10,000. And then I'm going to divide both sides by 2. So x equals 5,000. Okay, you can plug that in, do all the math, and you'll see that that answer is correct. Okay. Number 4, this one's going to be a little more complicated because we have to use the properties of logarithms to put all this together into one logarithmic expression. So if you'll think back, the product property, we've got these two logarithms with the same base. We're adding those together. So what I'm going to do is I'm going to multiply these two expressions together using the product property of logarithms. Okay, so next thing I want to do, I want to multiply these two binomials. I get x squared plus x minus 2. Now I've got the logarithm in simplest form over here, isolated by itself. So let's rewrite in exponential form. So I get 10 to the 1st power, which is over here, equals this quadratic trinomial. Okay? So now we've got a quadratic equation that we have to solve. So let's get everything on the left side set equal to 0. So I'm going to subtract 10 from both sides. Okay? I can factor this, thankfully, into x plus 4, x minus 3, okay? Set each of these factors equal to 0, okay? Use the 0 product property, and I get z equals negative 4 and positive 3, okay? Now, when we were solving radical equations, one of the things we had to do was check for what we called extraneous solutions, and that can happen here as well. So you need to check your work, plug in negative 4, and what happens here is you get the log of negative 2, okay? Well, 10, remember the base here is 10. 10 to any power is never going to be negative 2, all right? So negative 4 is what we call extraneous. If you plug in 3, you're going to get a positive value here. 3 plus 2 is 5. 10 to some exponent can be 5, all right? If you plug in 3 here, you get 2. So 10 to some power can be 2, all right? So you need to check. Anytime you get your solutions, you always need to check and make sure that each of those solutions actually is a solution. And in this case, negative 4 is not, so it's considered extraneous. All right, so let's give number 5 a try here. Logarithm's already isolated, so we can go ahead and convert to exponential form. So 2 squared, which is 4, equals this quadratic trinomial here, x squared minus x minus 2, okay? We have a quadratic, so let's get everything on one side, set it equal to 0. So I'm going to subtract 4 from both sides. Again, thankfully this can be factored, so I don't have to use the quadratic formula. I factor that as x minus 3x plus 2. use the zero product property, and I get my answers, -2 and +3, okay? Now, again, you want to check these and see if either of these is extraneous. When you plug in -2 here for both these x's, you're going to get a value of, so -2 squared would be 4, +2 is 6, -2 is 4. So 2 squared equals 4. Okay, if you plug in 3, it's going to work also. 3 squared is 9, -3 is 6, -2 is 4. Okay, so that makes this whole thing 4. And again, 2 to the second power is 4. So both of these are going to work. No extraneous solutions in problem 5. Okay, and finally, problem 6 here. A couple different ways to do this. I'm going to do it the way where I'm going to bring all the logarithms over to one side and set it equal to 0. And then the reason I'm doing it this way is I want to, make sure we're incorporating those properties that we learned previously. Okay, so these two, we're going to use the product. This is going to be our numerator, so it's going to be log base 5 of x times x plus 1. And then because there's a negative sign here, the 20 would go in the denominator. So using the product and quotient properties, I can convert this trinomial here into one logarithmic expression. Okay, so now we want to convert to exponential form. All right, so 5 to the 0 power is 1. That's where this 1 comes from, equals x times x plus 1 over 20. Okay, I'm going to multiply both sides by 20, and then I'm going to simplify the numerator here. So 20 times 1 is where this 20 comes from. X times x is x squared. X times 1 is x. Okay, so I've got a quadratic here. Let's get everything on the same side. So I'm going to subtract 20 from both sides, and now I'm going to factor. Okay, x plus 5 times x minus 4 equals 0. Use the zero product property, and I get these two answers, -5 and +4. Okay, right away you should recognize x can't be -5, okay, because 5 to no power would ever be -5, okay? So -5 is going to be what we consider extraneous, all right? If I plug in 4, it's going to work. Okay, you can plug that into your calculator and see that the left side is equal to the right side. All right, so that's how you solve logarithmic equations.